Hi everyone. So let's start now. This is our weekly quiz 26 discussion part 2. In the part 1, we have already seen question number 1 to 10. So for this weekly quiz 26, in the part 1, discussion part 1, in that we have seen question number 1 to 10. Okay, in this part, this is our part 2. In this part, we will see question number 11 to 15. All these questions in this weekly quiz. So this is a weekly quiz for theory of computation. In this weekly quiz, the concept, the topic that we have, that is finite automata and regular expression. This is our topic for this weekly quiz. And we have already seen question 1 to 10. Now we will see question number 11 to 15. Remember, all these questions are taken from Stanford University. Okay, all of them, all these questions, these are taken from Stanford University. So let's see. Now, let's start. So let's see this question. This is our question number 11. This language is given to you. The question is asking what is the regular expression which will describe this language. So this is a question taken from Stanford University. You can notice. So let's see this question. The language is given to you, that is a power n, b power n. N is natural numbers. N belongs to set of natural numbers. So you can see. So which regular expression will describe this language? So you can notice this language, this is not regular, yes or no? This language is non-regular, correct? This language is non-regular. This is a non-regular language. So if this is a non-regular language, can you create regular expression? Can you create regular expression? No, you cannot create regular expression. So whatever regular expression you create, that will be wrong. Okay, because this is a non-regular language. Remember one thing, if you have any regular expression, then what will be the language of this regular expression? Tell me. Then what will be the language of this regular expression? That will be regular. Okay, the language of this regular expression will be a regular language. Yes or no? And for every regular language, there exists a regular expression. If you take any regular language, then there exists a regular expression. And remember, if you have any regular expression, then what it will generate, what it will describe, it will describe a regular language. So very simple point. Now, if you have a non-regular language, if your language is non-regular, if you have a non-regular language L, then you can easily notice there is no regular expression. Yes or no? There is no regular expression to describe it. There is no regular expression to describe it, to describe L. Okay, so very simple point, that if you have a non-regular language, then no regular expression can describe it. So, okay, so very simple point. So I can say these regular expressions, they cannot describe this language, because this language is non-regular. Okay, because this is a non-regular language. So that is the reason I can say answer will be none of the above. Okay, very simple. So this is a nice question, let me tell you. Okay, but you can see this is very simple. The language is non-regular. So regular expression you cannot write. Whatever regular expression you write, that will be wrong. Okay, whatever regular expression you write, that cannot describe this language. Okay, so very simple. So for this question, answer will be option D. Now let's see. Now let's move on. Now let's see this question. Let's solve this question. So what this question is asking, this is your question number 12. The question is saying that for the following language over the indicated alphabet, construct a DFA with fewest number of states. Construct a DFA with fewest number of states, means the question is asking minimal DFA. Create a minimal DFA for this language that accepts precisely the strings which are in this language. Okay, so create a minimal DFA which will accept this string, which will accept this language. The alphabet is ABC. Construct a DFA for this language. W belongs to sigma star. Remember, sigma is ABC. So W belongs to sigma star, means W is a string over this alphabet. W is a string containing ABC. W contains exactly 2C. What the number of states in the DFA? So let's see. First, can you write the regular expression for this? Your alphabet is given to you. Alphabet is A, B, C. This is your alphabet. And the language is also given to you. That is, in this language, you have strings over this alphabet. Okay, you have strings over this alphabet such that W contains exactly 2C. Exactly 2 C's. Okay, W contains exactly 2 C's, not more than 2C, not less than 2C. Okay, so tell me, you can see this is your language. Can you write the regular expression for this language? What will be the regular expression to describe this language? Tell me, what will be the regular expression to describe this language? So W contains exactly 2C. Okay, so you have, this is the C, this is the C. Okay, so tell me, if this is the C, this is the C, then what you can put here? Tell me what you can put here. You can put anything from A, B. 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 So your regular expression will be A or B whole star, C, A or B whole star, C, A or B whole star. Yes or no? This will be the regular expression. Correct? Very simple. Now let's see the DFA. Let's see the minimal DFA. Now let's create minimal DFA for this language. Okay. So let's see. Remember, we want exactly 2 C's. Okay. Anything can come, A or B, anything comes. I don't care. See, this is what we want. This is what we want. If A, B's are coming, we can ignore. Okay. We want exactly 2 C's. We want exactly 2 C's. So you can see in the initial state, we are waiting for 2C, right? Yes or no? In the initial state, you are waiting for 2C. You are waiting for 2C. If A, B are coming, you can ignore. If A, B, they are coming, you can ignore. If C comes, then you will wait for 1C. Then you will wait for 1C. Yes or no? Okay, remember, in the initial state, you are waiting for what? Tell me. In the initial state, you are waiting for 2C. You are waiting for 2C. Okay. In this state, you are waiting for how many C? You are waiting for only 1C. Okay. In this state also, if A, B are coming, you can ignore. You can ignore. Okay, just ignore. If one more C will come, then you can go to final state. Now you are waiting for 0C. Yes or no? Now you are waiting for 0C. Okay. Now if A, B are coming, you can ignore. A, B are coming, you can ignore. But if more C are coming, then what you will do? If more C will come, then you can go to dead state. If more C will come, then you can go to dead state. Okay. So very simple. If more C are coming, you can go to dead state. So this is your minimal DFA. This is the minimal DFA that you will get. So in the minimal DFA, you have 4 states. Okay. Very simple. This is your minimal DFA. In minimal NFA, how many states will be there? In the minimal NFA, how many states will be there? Tell me. In the minimal NFA, if I ask you how many states in the minimal NFA for this, so you can see the minimal NFA will be like this. This is your minimal NFA. Okay. You can see this is your minimal NFA. So minimal NFA has 3 states. Very simple. This is your minimal NFA. Okay. Very simple. So this is the idea. So for this question, the answer will be 4. For this question, the answer will be 4. Okay. Minimal DFA has 4 states. So this is a simple question. Now let's move on. Now let's see this question. Question number 13. So the question is asking, read the question carefully. For the following language over the indicated alphabet, construct a DFA with the fewest number of states. DFA with the fewest number of states. So again, we are asking minimal DFA. Okay. That accepts precisely the strings which are in the language. The alphabet is English alphabet, A to Z. This is your alphabet. Construct a DFA for this language. Strings, English words. Okay, W is a string over sigma. This is your sigma. So W is a string over all these symbols A to Z. W contains the word COA as a substring. Okay, so this is the question. So can you write the regular expression for this? Can you write regular expression for this? Remember, your alphabet is A to Z. Your alphabet is A to Z. This is your alphabet. And what is your language? Your language is containing COA. Okay, so you have strings which contain, W contains this substring COA. Okay, this is what it contains. So tell me, what will be the regular expression for this language? What will be the regular expression? You want to contain COA. This is what you want. You want to contain COA. This is what you want to contain. Okay, if you want to contain this, here you can put anything. If you want to contain this, here you can put anything, sigma star. Here also you can put anything, that is sigma star. Okay, so your regular expression will be sigma star, you should contain COA. This is your regular expression. Okay, this complete expression, this is your regular expression. So this is your answer. This is the regular expression. Okay, yes or no? Very simple. Now let's see the next. Let's see minimal DFA. Now let's see the minimal DFA. We want to create minimal DFA for this language, which contains COA. So how many states will be there in the minimal DFA? You can notice in the initial state what we are waiting for. In the initial state, what we are waiting for? We are waiting for COA. This is what we are waiting for. In the initial state, this is what we are waiting for. We are waiting for COA. Okay, remember, this is what you want. Please understand that this is what you want. You want to contain COA. This is what you want to contain. So tell me, what is the first symbol that will trigger you? What is the first symbol that will trigger you? That will trigger you. C will trigger you. Yes or no? This symbol C will trigger you. Anything other than C, what will happen? Anything other than C, anything other than C, what will happen? Ignore. Anything other than C, ignore. Agree? Anything that comes other than C, okay, whatever comes, you can ignore. Whatever comes, okay, for example, B, R, O, A, B, okay, so whatever comes, you just ignore. You just ignore. Whatever comes, you just ignore. Ignore. Okay. Then you are waiting for C. You are waiting for C. So C has come. Okay. When C is coming, then what you are waiting for? Please tell me. Now what you are waiting for? Now you are waiting for OCOA. This is what you are waiting for. You are waiting for this. Okay. So remember, this is the first symbol which will trigger you. Which will trigger you. Any other symbol, if any other symbol is coming, then you can ignore. In this state, you are waiting for O. Okay, so if O comes, then where you will go? Tell me. If O comes, then you will wait for COA. If C comes, then you will wait for OA. Okay, in this state, if O comes, you will wait for A. In this state, if A comes, then now whatever comes, I can accept. Now whatever comes, I can accept. Yes or no? Now whatever comes, I can accept. So this is the structure of the DFA. I hope you understood. See what I am saying. Please understand. We want to contain COA. We want to contain COA. This is what we want to contain. Okay, very simple. Now for this, the initial state is, in the initial state, you are waiting for COA. Okay, this symbol, if the first symbol is C, then it will trigger you. Then you will go to O, then you will wait for OCOA. If any other symbol comes, then you will ignore. Then you will ignore. Okay, in this state, if O comes, then you will wait for COA. Then you will wait for COA. In this state, if C comes, then you will wait for OA. In this state, if O comes, then you will wait for A. And if A comes, then that's it. Then you can accept everything. Now whatever comes, I don't mind. Okay, because I want to contain this substring. I want this substring. Okay, so now here you can notice whatever comes, I will accept. Whatever comes, I will accept. Is this the DFA? Please tell me, is this the DFA? This is not the DFA. Okay, so you can see which state is over. Tell me which state is over. I can say this state is over. This state is over. These two states are done. These two states, these are done. Okay. Now tell me, in this state, with symbols, what you will do on other symbols? For example, you are waiting. Okay. For O, you will go here. For O, you will go here. Okay. You have already seen C. Let's see this state. Please focus on this state. Which state? This state, O, C, O, A. Okay. Let's focus on this state. In this state, what you have seen, please tell me. What you have already seen in this state, what you have already seen, please tell me. You have already seen C. You have already seen C. Okay, this is this state. Here you are. Here you are. Okay, here you are. Right. Okay, you have already seen C. Now here you are. You are here. Now you tell me one thing. If another C comes, what you will do? You are waiting for O, C, O, A. Remember, here you are waiting for what? Here you are waiting for O, C, O, A. And what you have seen? Okay, what you have seen? You have seen A. You have seen C. What you have seen? You have seen this C. If another C comes, what you will do? If another C comes, then again you will wait for O, C, O, A. Yes or no? If another C comes, then again you will wait for. So you can easily notice, if C comes, then what you will do? Then again you will wait for. So what you will do here? Then again you will wait for O, C, O, A. Okay, so if C comes, then you will go to self loop. If C is coming, you will go to self loop. Okay, very simple, very simple. Now tell me one more thing. If O comes, then you are here. Okay. If A comes, where you will go? If A comes, please tell me. If A comes, then whole progress is gone. Yes or no? If A comes, then whole progress gone. Then whole progress gone. If A comes, then whole progress is gone. If A comes. Okay. If A comes, then whole progress is gone. Means you will wait for what? Tell me. Whole progress is gone. Means you will wait for the entire string. OC. Okay. Then you will wait for the entire string. That is CO, COA. Okay. So you will go to initial state. If A comes, you will go to initial state. If you notice, any other symbol comes, what you will do? If any other symbol comes, means any symbol other than C. Any other symbol other than C, A, C, O. If any symbol comes other than C, O, then what you will do? If any symbol comes other than C, O, then also the same thing. Then also the same thing. The whole progress gone. Then the whole progress is gone. You will wait for CO, COA. So you can notice that actually I can say that any symbol comes other than C, O. Any symbol comes other than C, O, you will go to initial state. Very simple. Now this state is also over. Okay. What about this state? In this state, you have seen C, O. You have seen CO. Now you are waiting for COA. Okay. In this state, you are waiting for COA. And you have already seen CO. Here you are. Okay. Here you are. Remember, you have seen CO. You are waiting for COA. Okay. In this situation, you can easily notice already this transition. We have already seen this transition. So this C transition we have already seen. What about O? If the symbol O comes, what you will do? Tell me. If the symbol O comes, remember this is the original string that you want. This is the original string that you want. If another O comes, then the whole progress is gone or not? Yes, the whole progress gone. Yes or no? If O comes, then again, what will happen here? Whole progress gone. Okay, whole progress, that is gone. Whole progress gone. Right? Yes or no? You want this. You want CO, COA. Okay, if this happens, then the whole progress is gone. Correct? Now, what else? What about A? What happens if A comes? Tell me. What happens if A comes? Let me know. What happens if A comes? COA. What happens? Then also whole progress gone. Then also progress is gone. Okay, then also progress is gone. Any other symbol comes. Actually, I can say that any symbol other than C comes. Any symbol other than C comes, the whole progress is gone. Yes or no? Any other symbol other than C, any symbol other than C comes, then whole progress is gone. Okay, so very simple. I can say in this state, in this state, if any symbol comes, okay, so any symbol comes other than C, so I can do like this. Then the whole progress is gone. Any symbol other than C. So now this state is also over. What about this state? Tell me, what about this state? OA. What about this one? Now let's see this one. You are waiting for OA. Remember, this is your original, this is the original thing you want. Okay, so you have already seen OA. Now you tell me. Sorry, you are waiting for OA. You have already seen COC. This is what you have seen. You have already seen COC. Now you are waiting for OA. You have already seen COC. And now you are waiting for. Now you are waiting for OA. This is what you are doing. Now you tell me, in this state, okay, in this state, you can notice I am talking about this state. If O comes, you know what to do. If C comes, what to do? Tell me. If C comes, what to do? Tell me. If C comes, what to do? Let me know. If C comes, what to do? Let me know. If C comes, then whole progress is not gone. You will wait for OCOA. Yes or no? You will wait for what? You will wait for OCOA. Correct? Okay, you will wait for OCOA. So if C comes, remember in this state, if C comes, you will wait for, in this state, if C comes, you will go here. Okay. What about the other symbols? What about if A comes, where you will go? If A comes, then where you will go? Then whole progress is gone. Then whole progress gone. Then the whole progress is gone. Okay. If any other symbol comes, if you notice, basically any symbol other than C, O, then the whole progress gone. Any symbol other than C, O, any symbol other than C, O, then the whole progress will be gone. Okay, then the whole progress will be gone. So I can say you will do like this. Okay, so from here, you will make this move on sigma minus C, O. Okay, very simple. Now this state is also over. What about this state? What about this state? Tell me. I'm asking this state where you are waiting for A, this state. This is your original word. You have already seen CO. This is what you have already seen. Now you tell me. Now let me know. For example, if C comes, then what you will do? In this state, I am talking about this state. In this state, if C comes, what you will do? Then how much progress is gone? Please tell me. If C comes, how much progress is gone? If C comes, then what you will wait for? C. If C comes, then you will wait for what? Notice CO. Okay, notice CO. Okay, you can notice if C comes, then this much progress you have made. This much progress you have made. Yes or no? So here you will wait for OA. So here you will wait for OA. Okay, so if C comes, you will wait for OA. If C comes, you will wait for OA. Simple, yes or no? Agree? Okay, what about this CO? If O comes, where you will go? If O comes, where you will go? Tell me. If O comes, tell me. If O comes, where you will go? Then entire progress gone. Then the whole progress is gone. You can notice, then the whole progress is gone. Whole progress is gone. Okay. Actually, if you notice, any other symbol comes other than C, A, then the whole progress is gone. Any symbol other than C, A. Already A, we already know. Okay, any symbol other than C, A, the whole progress will be gone. So I can say something like this. Any symbol other than C, A. So this will be your minimal DFA. Okay, so you can just check it. Like this, it will happen. For any symbol other than C, A. Okay, so this is your DFA. This is your minimal DFA on your screen. Is this clear? Please tell me. So you can notice, ultimately you can notice the answer is 6. The answer is 6. Please tell me one thing. In the GATE exam, if this question comes, will you create this entire DFA? Will you create this entire DFA? In the GATE exam, if this question comes, will you create this entire DFA? Will you create this entire DFA? Let me know. No, don't create this entire DFA. See, these languages, notice, containing substring, these languages, whatever alphabet you have, you can have any alphabet. Okay, whatever alphabet you have, for example, let's assume A, B, whatever alphabet you have. Okay, or you can say A to Z. This language that you have, which language? I am talking about language where you have containing substring W, where the length of W is, let's assume that is M. Then tell me what will be the number of states in minimal DFA? Then what will be number of states in minimal DFA? Tell me, what will be number of states in minimal DFA? Then that will be M plus 1. Okay, that will be M plus 1. Okay, this will always happen. This will always happen whatever alphabet you take. See, this will always happen whatever alphabet you take. Whatever alphabet you take, this will always happen. Whatever alphabet, whatever sigma you take, and whatever W you take, if the length is M, then this language containing substring, this language will have M plus 1 states. Yes or no? Whatever alphabet you take. For example, if your alphabet is unary, will it happen? If your alphabet is unary, and I am saying that W contains, okay, for example, W contains AA. Will it happen? Yes, it will happen. Okay, W contains AA. W should contain AA. You should contain AA. So this is the DFA that you will get. Yes or no? This is the DFA that you will get. Is this the minimal DFA? Is this the minimal DFA? Please tell me. Is this the minimal DFA? Let me know. 1, 2, 3. Is this minimal DFA? Yes, this is minimal DFA. Okay. Yes, this is minimal DFA. So you can notice this is your W. This is your W. Length of W is 2. And the minimal DFA has how many states? Minimal DFA has how many states? That is 2 plus 1. That is 3 states. Yes or no? And you can notice this is a minimal DFA. You can easily notice this is a minimal DFA. Okay. Is this point clear? See, this is what I'm saying. Whatever sigma you take, whatever sigma you take, containing substring W, this W should come from sigma star. Yes or no? This W should come from sigma star. This W must come from sigma star. For example, what I'm saying that, for example, if your alphabet is this, A, B, and I ask you, containing substring ABC, your alphabet is this, your alphabet is AB, and I'm asking containing substring ABC. That is nonsense, right? Yes or no? That is nonsense. Okay, so here that will be nonsense, correct? Is this point clear? If your alphabet is this, and if I ask you language containing ABC, so that will be nonsense. So that is the reason, okay, you can easily notice whatever alphabet you take containing substring W, which is coming from sigma star, if this length of W is M, then the number of states in the minimal DFA will be M plus 1. Okay, so remember, for this question, please understand, for this question, tell me how much time you will take to say that answer is 6. How much time you will take for this question? If this question comes in the GATE exam, will you create minimal DFA? Will you create minimal DFA? Will you create minimal DFA? No, don't create minimal DFA. Don't create minimal DFA. Okay, this is a standard language. This language is standard. This language is standard. So you can simply say that answer will be 5 plus 1, these many states. Okay, answer will be 5 plus 1, these many states. Okay, very simple. So you can just take, I can say, you don't have to create DFA. No. Okay, don't create DFA. Don't do that. For this language, this is a standard language. This language is standard. So you can say answer will be 6 states. Okay, simple. Now let's move on. Now let's see this question. Question number 14. This question is also taken from Stanford. You can see. Question number 14. Okay, this question we have taken. Now let's see this question. What this question is asking. See this. The question is saying the state elimination algorithm gives a way to transform finite automata into regular expression. This algorithm we have seen, yes or no? Means if you have a finite automata, DFA or NFA, if you have a finite automata DFA or NFA, then if you want to convert this to regular expression, then which algorithm we have seen? Please tell me. Which algorithm we have seen? We have seen, if you remember, state elimination. We remove the states. This state elimination algorithm we have already seen, correct? We eliminate the states one by one. Okay, we eliminate the states one by one. This algorithm we have already seen. Now you can see the state elimination algorithm gives a way to transform finite automata to regular expression. It's a real beautiful algorithm once you get the hang of it. So we thought of, okay, giving you one question. Okay, so like this. Actually, this question is taken from Stanford and the same language was used. This same language has been used. So I have put it as it is. Okay, let's see. In the following generalized NFA, this is your following generalized NFA. Okay, this is your NFA. Now we want to remove state Q1. This state Q1, this yellow state we want to remove. We want to remove this state. Now what the question is asking, if we remove state Q1, then please tell me one thing. If I remove this state Q1, then how many edges I have to take care? Tell me, if I remove this state Q1, then how many edges I have to put? If I remove this state Q1, I am removing this state Q1, then how many edges I have to put? Please tell me. Then I have to put one edge from QS to Q2. I have to put one edge from QS to Q2, yes or no? One edge I have to put from Q2 to Q2. Okay, yes or no? One edge I have to put from Q1 to Q2 to Q2. Okay, so you can easily notice, if I remove this state Q1, then I need to put edge from QS to Q2. Also, I need to put edge from Q2 to Q2. These are the state. These are the things I need. Okay, these are the two edges I need to put. Two edges. When delete Q1. When you delete this state Q1, then these two states you need. These two edges you need. Okay, so you can see. Now, another edge is from Q2 to Q2. One edge is from QS to Q2. Okay. What regular expression should go on this edge? What the question is asking? The question is asking about which edge? Tell me. The question is asking about this edge. Okay, what regular expression should go here? This is what the question is asking. Okay, so if you delete Q1, then which regular expression will come here? Please tell me. If you delete Q1, see, very simple. If you delete Q1, then you can notice that you are going R21, then any number of times R11, then R12. Okay, the regular expression you will get, that will be like this: R21, then any number of times R11, and then R12. Yes or no? Agree? Please tell me. Very simple, right? From Q2 to Q2. How can you go from Q2 to Q2? Tell me. How can you go from Q2 to Q2? From Q2 to Q2. You can take R21, then you can take any number of times R11, and then you can take R12. So this is the regular expression you will put on Q2. Okay, so for this question, the answer will be R21, R11 whole star. So this will be the answer. Okay, very simple. Answer will be option D. Now tell me one more thing. Which edge you will put on this edge? Which regular expression you will put on this edge? What you will put here? Which regular expression you will put? Which new regular expression you will put on this edge? Actually, that is already given here. That is already given. Basically, you will put epsilon, then any number of times R11. Okay, you will put epsilon, then any number of times R11, and then followed by R12. Okay, so very simple. This is already given to you. So this is a very simple question. I hope this is clear. You can see, if you delete this Q1, then the question is asking which regular expression should go on this edge. Which regular expression should go on this edge? So you can easily notice your answer will be, that will be option D. Option D will be the answer. Okay, quite simple. Now let's move on. Let's see this question. Question number 15. Let's see. Which of the following statements is or are true? Some statements are given to you. Which of them are true? The question is asking for true. If L is non-regular, then there exists a NFA that accept L. No. If L is non-regular, then you cannot have any finite automata. Yes or no? If your language is non-regular, if you have a non-regular language L, then what it means? It means there is no DFA for L. There is no finite automata for L. Okay, and this is two-way. This is two-way. Okay, so you can see non-regular means there is no finite automata for L. And if there is no finite automata for L, that means that is non-regular. Okay, so you can see option A, that is false. If L1, L2 are languages such that L1 is proper subset of L2, L2 is non-regular, then L1 must be non-regular. This statement, what about this statement? This is also false. What is the counterexample? Tell me. What is the counterexample? See option B. What option B is saying? Option B is saying that L1, L2 are languages. L1, L2 are languages such that L1 is proper subset of L2. And L2 is non-regular. This is non-regular. This is given to you. This is non-regular. This is given to you. So you can see that this L1 may or may not be regular. Yes or no? From here you can notice that L1 may or may not be regular. L1 may or may not be regular. L1 may or may not be regular. L1 may be regular. L1 may not be regular. Okay, can you give me a counterexample? Yes, you can easily give me a counterexample. What you can do for option B? For option B, L1. For example, you can take this language A power n, B power n, where n is greater than equal to 0. You can note this is your L2. This language is your L2. This is your L2. And you can note this is non-regular. This language is non-regular. Okay. Now what you do? You give me L1. You give me L1 which is regular, and you give me L1 which is non-regular. Give me both. Give me L1 which is regular and give me L1 which is non-regular. Yes, you can give me L1 which is regular. What is that? You can give me regular L1 which is regular. Can you give me A star, B star? 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 No. No, this is not a subset. Okay, remember, this is not a subset. This is not a subset of L2. This is not a subset of L2. So you cannot do this. Okay, but of course you can give me any finite language. See, you can always give me finite language. Whatever finite language you want, you can give me. For example, you can give me this language AABB, comma AAABBB. That's it. Yes or no? This is finite. Any finite language you can give me. Can you give me L1 which is non-regular? Can you give me L1 which is non-regular? Yes, you can give me this language A power 2n, B power 2n, where n is greater than equal to 0. This is also non-regular. This is also non-regular. Okay, you can give me this language, you can give me. Very simple. This is also non-regular. You can see A power 2n, A power 2n. This is a proper subset of L2. This is your L2. And you can notice this language is proper subset of L2. So very simple, you can see this statement B, that is false. What about statement C? The regular expression, they generate the same language. These two regular expressions, this regular expression and this regular expression, A star, B star, they generate same language. They are not equivalent. They are not equivalent. Okay. For example, here you have all the strings. For example, this can generate what? Tell me. Give me a string which will work as counterexample. For example, this can generate BA, BA. This cannot generate. This cannot generate BA. Okay, very simple. So like this, actually this is sigma star. It can create every string. Okay, so this is also false. What about the next? All non-regular languages are infinite. Every non-regular language is infinite. Yes, every non-regular language will be infinite. Why? Tell me why. Every non-regular language is infinite. Why? Because if it is finite, then it will be regular. Yes or no? We already know that every finite language is regular. Every finite language is regular. Can you prove it? Can you prove it? Can you prove it? Please tell me. Can you prove it? Every finite language is regular. Can you prove it? Yes. You can create a regular expression. You can create a regular expression. See, if this is your finite language, W1, W2, and so on, Wn. This is a finite language. This is a finite language. So you can easily create a regular expression. You can easily write a regular expression for L. Tell me what your regular expression for L. What will be the regular expression for L? That will be W1 or W2 or Wn. This will be the regular expression for. This is the regular expression for L. Yes or no? Yes or no? Is this infinite? Is this regular expression infinite? Like, for example, is this regular expression infinite? No. Your language is finite. Your language is finite. So this regular expression, this is also finite length. Okay, so you can see very easy. So this is the regular expression for this language. So you can see every finite language is regular. Means if you are finite, if language is finite, then it is regular. Yes or no? If language is finite, then it is regular. If L is a finite language, then it is regular. What are the contrapositive? Tell me what are the contrapositive? What are the contrapositive? The contrapositive will be that if L is non-regular, then L is infinite. Then L is infinite. Yes or no? This is the contrapositive. So you can see if the language is non-regular, then definitely it is infinite. So I can say this option D, that is true. So for this question, the answer will be option D. Okay. So these are all the questions. This is your question number 15. So we have seen all the questions in this quiz. In this quiz, each and every question we have seen. So please tell me, all these questions, are they clear? Anyone has any doubt? Let me know. All these questions, are they clear? Please tell me. Is there any question which you did wrong in this quiz? In this quiz, many students got full marks. In this quiz, if you check, then I think many students are there who got full marks. Okay, so if you did some mistake, did you understand what is your mistake? Satyam is saying that I did one wrong. Ravi is also saying I did one wrong. So did you understand your mistakes? One wrong, two wrong does not matter. Okay, one wrong, two wrong, three wrong. You can do 5 wrong, 10 wrong. But now did you understand your mistake? Please tell me. Did you understand your mistake? What mistake did you make? Okay. So I hope you liked these questions. These are very simple questions, but all these questions are standard questions taken from Stanford University. Okay. All these are, I can say, standard Stanford questions. So I hope you liked the questions. Okay. So please tell me, give me feedback of this quiz. Did you like this quiz? Let me know. Okay. So let me know your feedback of this quiz. Very simple questions. See, all these questions, these are simple questions. These are not complicated questions. All of them, all the 15 questions, these are very simple, nice questions. Okay. We have seen all the questions now. Okay. So thank you, everyone. I will give you more such quizzes. Okay. More such quizzes I will give you from the top universities. Stanford, IITs, Berkeley, ISC Bangalore. Okay, so all these top colleges, from these, I will collect GATE relevant questions. I will collect and I will give you more such quizzes. Okay. Okay. Thank you, everyone.